Last year, we looked at the very close conjunction of Jupiter and Saturn. As you can see from this image, they are much further apart, yet still close. Jupiter in the top left, Saturn in the top right of the image, and both a few degrees above the horizon from the northern latitude. You're looking through a significant amount of air still in the northern hemisphere. Jupiter, about 2.3 times as much air or air masses as if it was directly overhead, and Saturn very close to 3 air masses. This is because both planets are quite far in the south at the moment in their orbits. A few years from now, they'll look better from the northern hemisphere, but of course worse from the southern hemisphere. In this video, I'm going to step you through where to find them and how to see them. We'll look briefly at what you can expect to see with a good pair of binoculars and give an overview of what's required to take a photograph through a telescope. On this channel, I will be producing more videos that go into greater detail of how to photograph and process planetary photographs in the future. But let's take a look at what we can see over the following few nights and for the rest of the year, looking without any optical equipment at Jupiter and Saturn. Here is the sky chart from Cartes du Ciel from a high northern latitude of about 50 degrees. On the 20th of August 2021, this is Jupiter's opposition, where it is not only closest to the Earth, but also appears largest and brightest, and is visible all night, rising when the sun sets. Here is Jupiter. Next to it we have the Moon tonight, and Saturn nearby as well. Nowhere near as close as they were around November of last year, but still close enough that you can see both planets fairly easily. And what I'd like to do is just show you first of all what happens hour by hour. Let's step it back to 9 o'clock just after sunset, and there sure enough is Jupiter rising and Saturn rising and the Moon tonight rising. 1 hour later, they're reaching a much higher altitude, just under 15 degrees for Saturn over here. By 11 o'clock, both of them above 15 degrees, both Jupiter and Saturn, and fairly similar altitude. At midnight, Saturn is approaching the meridian, getting about as high as it can get. And that's not very high, by the way. That's not even 20 degrees. Just about 20 degrees rather. 1 o'clock, Jupiter approaching the meridian, Saturn starting to sink down towards the southwest. Jupiter, you could see, is further north than Saturn and higher up in the sky than Saturn. And it makes a significant difference. As the night goes on, they're both now setting. And then by 4 o'clock in the morning, Saturn's almost gone. By 6 o'clock, we're losing Jupiter. Once you've located Jupiter and Saturn in the sky, you might want to use a small telescope or binoculars to get a closer view, and you might want to take some photographs as well. Now, taking photographs with a short camera lens is going to give you the scene, but they'll just look like bright stars. If you want to see any details, you're going to need at least a long telephoto lens, or a simple afocal technique with binoculars on a tripod or a small telescope. Focus the instrument first using your eye, and then hold the camera up to the eyepiece and take your pictures. And you can get little brackets that hold them in place. But if you want to get the best resolution, you're going to need a fairly large telescope and a camera that attaches directly to the telescope. This is an astronomical CCD camera, and the great thing about it is that all the pixels in the camera are monochrome, so it doesn't get any color information at all. And just like the first days of color photography, the way to get the camera to see color is to use color filters, red, green, and blue. And they're rather weird. They are dependent on the angle with which you view them. And the reason for that is that these are interference filters. So what I'm going to do is put the filters into this filter wheel, and this allows you to rotate the filter and position each filter one at a time in the light path of the camera. So for example, if you were using this red filter, notice how the color changes with angle. If you use the red filter and place that in front of the camera, then all the pixels of the camera are perceiving the red light. They won't get any blue or green. And so the idea is to photograph an object like a planet, Mars or Jupiter or Saturn, with red and then green and then blue filters. We're in position 1, and this is going to be the red filter in position 1. Position 2, quite logically, the green filter. Did you hear the little click? There's a little click stop that tells you positively when you've reached the right position, because you want repeatable positioning on these filters. There's position 3, green filter. This is the camera with an adapter to attach it securely to the filter wheel and another adapter to attach it to the telescope focuser. The light comes in from the telescope through the filters, and here you can select the color of filter that you want so that the monochromatic camera will receive the correct wavelength of light. Of course, the camera is no good without a telescope. This is set up to look through the telescope visually with an eyepiece like this. And of course, that's not what I want to do now. I want to photograph planets. So we take the eyepiece out, and in its place, here is the camera. So it goes straight into that place. And the idea is to have a fairly solid connection. Just rotate it around so that it's easy to lock it in place, and to access the filter wheel to select the different filters. That's what we can see tonight. What I'd like to do now is step you forward one day at a time to see the changes. So if you're watching this on the 21st, well, the moon is now closer to Jupiter than to Saturn. Toggle those backwards and forwards. It's the motion of the moon in one night. The motion of Jupiter and Saturn relative to the background stars is not apparent at all. So let's go and step through a few more days. You can see that Jupiter is slowly moving against the stars. The program is set to track Jupiter, but that's really not an obvious motion. It's not going to look very different from one night to the next. So let's speed things up a bit. We're on the 1st of September now. Let's go 10 days at a time. And the 10-day increments make a bigger difference. You'll see that we're now losing Jupiter and Saturn, but this is 1 o'clock in the morning. And so if we just step it back a little bit by a few hours, bring them back to the meridian, and now it's a much more reasonable 9 o'clock in the evening. And then step forward 10 days at a time. You can see that Jupiter has got closer to Saturn, making a nice triangle with these two stars in Capricornus on the end of September, the 30th of September. And now let's step forward 10 days at a time. End of October, end of November, and they're still visible through December, getting rather low by the end of the year. In February, the Sun will be in conjunction with Saturn, and Saturn won't be visible, and a few days after that, Jupiter in conjunction as well.